In question 1, we have to start by multiplying everything by 2 to get rid of the fractional term on the right. So we do that term by term. 4 times 2 gives us 8 into 1 minus x. Minus 2 times 2 gives us minus 4 into 3 plus x. Then on the right hand side, again multiplying by 2, 2 times 3 is 6. And then the second term just becomes its denominator, multiplying by 2, so we get minus bracket 1 plus 2x, close bracket. Multiply the brackets, we have 8 minus 8x minus 12 minus 4x equals 6 minus 1 is 5, and minus 2x. Then we want all the x terms on the left. So we've got minus 8x minus 4x is minus 12x. Bring the minus 2x across the equal sign, becomes plus 2x. So minus 12x plus 2x is minus 10x. And everything else has got to go on the right hand side. So 8 minus 12 is minus 4. Crosses the equal sign to become plus 4. So on the right hand side we're going to have 5 plus 4 is 9, and therefore x is equal to, if we divide both sides by minus 10, then we end up with 9 upon minus 10, which is the same as minus 9 upon 10. Or we can use cross multiplication to just move the minus 10 down underneath the 9. Question 2. We have to use the quotient rule, which says that if we got f, function f divided by a function g, the derivative, which we can denote with a dash, is given by f dash g minus g dashed f over g squared. So in this case, f dash derivative of the top function is just going to be 3 times the bottom function, minus g dash derivative of 2x plus 3 will be 2 times f, the top function, all over 2x plus 3 all squared, or g squared. Then we can tidy up the numerator. It's going to give us 3 times 2x is 6x, minus 2 times 3x, so minus 6x, so no 0 for the x term. Then we have 3 times 3 is 9, minus 2 times minus 2 is plus 4, so 9 plus 4, 13, over 2x plus 3 all squared. Question 3. We have to find the derivative first of all of the given equation. So dt by dt then, for the constant 10, derivative is 0, and then we need to use product rule on 5t e to the minus t, remembering that product rule says if we've got f times g, the derivative is given by f dash g plus g dash f. So if we call 5t f, and e to the minus 3t g, then d by dt is f dash, so derivative of 5t is 5, times the second function, e to the minus 3t, plus the derivative of the second function. Well, the derivative of e to the kt is ke to the kt, so in our case k is minus 3, so it's going to be minus 3 e to the minus 3t times the first function, 5t. Then we can look to see if there's any common factor. Well, we've got 5 in both terms and e to the minus 3t. in both terms. So for the first term in the bracket, divide the first term, original term, by the common factor, so it's going to give us 1. The second term, the 5's cancel, the e's cancel, leaving us just with minus 3t. Then in part B, we have to find the value of small t when the derivative is equal to 0. Now if we've got the exponential term times the bracket equal to 0, we must put the bracket equal to 0. So 1 minus 3t equals 0, then 3t equals 1, and therefore t is equal to 1 over 3. So 1 minus 3t will be equal to 0, tells us that 3t equals 1, and therefore t is equal to 1 over 3. Question 4, we have to integrate both sides. Left hand side, the s by the t integrated is just going to become s, because the integral of the derivative is just the original variable. On the right hand side, you can put down the 100 first, because the integral of 100 times something is the same as 100 times the integral. And then we want the integral of 1 over t plus 2. Well, we should remember that when we see 1 over something, the integral is going to probably be a natural log. Well, that is where it's a single variable plus a constant that we're integrating. And then we need to remember that the integral of a constant is just the constant times the variable. So the integral of 3 with respect to t is just 3t. Because we can think of 3 as being 3t to the power of 0. Integrate t to the power of 0 using a parallel rule. We increase the power by 1, so t to the 0 becomes t to the 1 divided by 1, or just t. Or just remember that the integral of a constant is constant times the integrating variable. Lastly, we need plus c, constant of integration. And then we can use the initial condition that s is equal to 200 natural log of 2 on the left hand side. And when t is 0, so on the right hand side we're going to have well, 3 times 0 is obviously 0, so we're going to have 100 natural log of 2 plus c, and therefore c is equal to natural log of 2 into 200 minus 100, which is just 100 natural log of 2, and therefore s can be rewritten as well, with 100 as a common factor, we're going to have natural log of t plus 2 plus 3t plus natural log of 2. Two natural logs can be combined to then give us 100 into natural log of 2 times t plus 2 plus 2t. That's making use of the fact that log a plus log b is the same as log ab.